Hello, so today we are going to talk about ratio tables and equivalent ratios, actually not ratio tables. So we're going to go back and review some things about ratios that you learned in step 2. And it's kind of similar to unit rates because you have to almost break it down a little bit, but we'll get more into that in a second here. So, what is a ratio table? A ratio table is a table, because the columns are filled with pairs of numbers with having the same ratios. So is a table where columns are filled with the same ratio. Okay, and remember that ratios have to share a common unit or label. Okay, so we will get into some examples of those in a second, but I just wanted to give you guys a definition of what that is. Okay, so our next definition to cover first are equivalent ratios. Okay, now if you remember, equivalent ratios express the same relationship between quantities. Okay, so that would be similar to saying if I had, let's say I had soda and juice. And actually I'm going to write that in different colors so you can see it a little more because this is kind of an example. So we have soda and juice. Okay, and so let's say I started out with 1 can of soda and 3 cups of juice. Equivalent ratio would mean that I'm going to multiply the same thing to my soda as I am to my juice. So if I had 2 cups of soda, or 2 cans of soda, how many cups of juice would I have? Now if you said I had 6 cups of juice, you are correct. Okay, so now if I had 3 cans of soda, you're probably thinking you're going to have 9 cups of juice, which again, you are correct, okay? So it's kind of like fractions when we're making them bigger, okay? What you do to the top, you have to do to the bottom. So that might help you a little bit if you think about it that way. So now we're going to do an example, okay? So this says, to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring would you mix with 5 cups of icing? Okay, so what I like to do is I like to go through and figure out what some important information is here. So if we go here, we have 6 drops of yellow food coloring, okay, and that is used to make 1 cup of white icing, and now we want to see what happens if we make 5 cups. So I think that the best way to do this is probably to make a table. Okay, so I'm going to make my table down here, and we'll come back to look at that in a second here. So I'm going to just draw it like this. Okay, so then I'm going to call this drops of yellow. Okay, draw this line here. We're going to call this one cups of icing. Okay, now if I go back up here, our original problem said we mix 6 drops of yellow food coloring, so I write 6 down in here. okay, with 1 cup of icing. Okay, so now we want to make this an equivalent ratio. So I put a 5 down here because we want to find out how many drops we need for 5 cups of icing. Now what did I do to get from 1 to 5? If you said multiply this by 5, you are correct. And as I mentioned earlier, it's similar to fractions when we find a common denominator. What we do to the bottom, we have to do to the top. So what we're doing to the bottom of this table, we have to do to the top. And I multiplied by 5 here, so now I must multiply by 5 here. 6 times 5 is 30. So my answer would then be 30 drops of yellow food coloring. Okay, and I'll just box that out a little bit so you guys can see that. Alright, and again, to get from 1 cup of icing to 5, we multiplied 1 times 5. So then if I get to 6 yellow drops, I have to figure out how much I need. So I multiplied 6 by 5, and that's where I got my 30. Okay, so that's an example of a table and also using equivalent ratios. Okay, so now we're going to, oh no, sorry, we have another example we're going to do here. Okay, so this one's going to lead us into something called scaling that we'll talk about in a second here. So we said Joey Chestnut won a hot dog eating contest by eating 66, okay, so I see this already, so I think I'm going to underline it because it might be important, 66 hot dogs in 12 minutes. If he ate at a constant rate, find about how many hot dogs he ate every 2 minutes. Okay, so we're just going to move this up a little bit here. And I think that, again, we might probably make a table. Right, so let's make this one blue. So we can make this here. Okay. I think we're going to say hot dogs up here because he ate hot dogs per minute. So the per tells us it's at the bottom of our ratio. So we have hot dogs here. And then we have time, and then specifically in minutes here. Okay, so we know right off the bat he ate 66 hot dogs in 12 minutes. Okay, so now what I want to do is I want to make this smaller. I want to figure out how much he ate in 2 minutes. Okay, so 2 is our end goal, but I might not know what I have to do to get from 12 to 2. So let's make this just a little bit smaller. So if I, let's divide this right here by 6, okay, so divide by, or not by 6, let's divide this by 2. So then I get 12 divided by 2 is 6, and what I do there, I have to do up here. So then I do 66 divided by 2, which would give me 33. So in 6 minutes, he eats 33 hot dogs. But that's not enough, because remember, the question wants us to find how many hot dogs he would eat at a constant rate within every 2 minutes. Okay, so now I need to somehow get from 6 to 2. So what can I do to get from 6 to 2? If your answer is divide by 3, you are again correct. Okay, so 6 divided by 3 is 2, so that checks out. So now we must do 33 divided by 3. And our answer is 11. So now we know that Joey Chestnut, so we can say, let's say, Joey eats 11 hot dogs every 2 minutes. Okay? And ratio tables are just an easier way for us to show our work and display the information we're trying to get to. You can kind of think about this as like trying to find the greatest common factor between the two. Okay? So if you could easily see right away that 6 goes into both 66 and 12, then go ahead and divide by 6. You don't have to take those baby steps of 2 and 3. But if that's easier for you to do 2 and then again do 3, that's totally fine too. There's no right or wrong way to simplify these things, okay? So now we're going to talk about scaling. Okay, and scaling is defined as multiplying or dividing, could be either one, two related quantities by the same number. Okay, so as I mentioned, we see this a lot in equivalent ratios, which is what we just talked about. Okay, so an example would be cans of corn are on sale for $4. Okay, so that's 10 cans of corn for $4. We want to find the cost of 15 cans. Okay, so a question we want to ask ourselves, is there a whole number that we can multiply 10 by in order to get to 15? Okay, can you think of any numbers that I can multiply 10 by to get to 15? Again, it's a whole number. Okay, so I personally don't think there is. So if we can't make the number bigger by multiplying, maybe we can make something smaller. Okay, so I want to think about my factors of 10. My factors of 10 are 1 and 10 and 2 and 5. Okay, so I do need a common factor between 10 and 4. Right here, common factor. So I think I'm going to divide both by 2. Okay, so now if I divide 4 by 2, I get 2. If I divide 10 by 2, I get 5. Now, is there something I can multiply 5 by to get to 15? Okay, this is where knowing your multiplication facts are going to make this a lot simpler. So, I mean, you might have to practice a little bit more, but it's going to make your life way easier if we know those right off the top of our head. So then, in order to get from 5 to 15, I can multiply this by 3. And what I do to this part right here, I have to do to the bottom part down here. So I multiply 5 by 3 to get 15. I multiply 2 by 3 to get 6. Okay? So, this is talking about, again, ratio tables and equivalent tables. Okay? So we solved that. Right now, during your note check, we're going to ask you about a code word. Okay? So now we're talking about tables. I'm going to tell you, Miss Zach's favorite holiday is Thanksgiving, okay? So our code word for this video is going to be Thanksgiving, okay? So getting back to some information, remember that scaling doesn't always mean we're going to make something bigger. Like, scaling can be multiplying or dividing, as we mentioned in our definition, okay? Just keep that in mind as you continue working. Okay, so we're going to do one more example before I have you guys go on and start your practice step, or your C step. And our question is, Santiago receives an allowance of $7 every week. How much does Santiago receive after 4 weeks? Okay, so we're going to make another ratio table here. Okay, so I'm going to draw it just like this. Okay, and we're going to have again, his allowance is in money, so we're just going to write our label there. And here we have number of weeks. Okay, so we know after 1 week, Santiago receives $7. Okay, so now I need to find my equivalent ratio. Okay, and remember, this is known as the same relationship between quantities, okay? So remember, what I do to one part of my ratio, I have to do to my other part, just like we do with fractions when we're finding the greatest common denominator, okay? So, if after 2 weeks, I need to find out how much Santiago makes, okay? So in order to get from 1 to 2, okay, we're going to write our 2 there, okay? I'm multiplying this week, or I make $7 every week. So if after 1 week I make $7, after 2 weeks, how much do I make? Okay, the easiest way to figure that out is to do 7 times 2. Okay, and then 7 times 2 is 14. Okay, so now we want to get to 4 weeks. So I think our best bet here is probably to go to 3 weeks next. Okay, so if I make $14 after 2 weeks, I can add another 7 here, and I'm going to get 21. Or I know I make $7 a week. This is my 3rd week, so I can also do 7 times 3. Okay, now to finish it up, because our question's asking us after 4 weeks, I can do 21 plus 7, and I get $28. Okay, so after 4 weeks, Santiago makes $28 as his allowance. Okay, so another cool thing about ratio tables is that they can allow us to use this information to build a graph. Okay? So what we're going to do is we want to know how much he receives after 4 weeks. Okay, so we're measuring our information based on how much money he makes per week. Okay, so we're going to graph this as money per week. Okay, so this is my X and that's my Y. So my order pair would be 7, 1. Okay, because remember our order pairs go in X, Y. Okay, and then I have an order pair of 14, 2. And I have an order pair of 21 and 3. And I have an order pair of 28 and 4. Okay, so I don't want to get into too much information about this because this is a section that you guys will be covering further on. But I just wanted to remind you that that's one cool thing about equivalent tables is that you can use them to create order pairs and to draw a graph, okay? So keep that in mind as we continue going on. And you guys can go ahead and start your C step. Don't forget to fill out your note check, otherwise you know, not going to receive your points. And remember that code word. Bye for now.